All right, this is number 12 from section 7.5, the simplex method. This is a pretty tricky one. There's just a lot going on here with like changing units from 100-pound batches to 1-pound boxes and minutes and hours. It's kind of annoying. So you just got to be careful with the setup here. If you read through this problem, basically there's a candy company and they're making three types of candy. And there's a chocolate shortage, right? So they can only get 120 pounds of chocolate in the next shipment. And this is like a weekly kind of a deal. So we're looking at what they should do for this next week, like how much of each type of candy should they make. They can make three types. They make fudge, they make chocolate creams. Oh, I guess it's up here first. Fudge, chocolate creams, and pralines. So those are going to be the three variables. You can double check at the end. Read the question, right? How many batches of each type of candy should they make? So really, how many of those 100-pound batches? So I'm going to make that be my variables, the 100-pound batches of fudge, creams, and pralines. So X1 will be the batches of fudge. X2 will be the batches of creams. And X3 pralines. And my objective function is to maximize the profit, maximum profit for the week. So max profit Z equals, and the profit is they get 50 cents for a 1-pound box of fudge, 40 for creams, 45 cents for pralines. But that's for 1 pound, so we're going to multiply by 100 to get dollars, right? So it's going to be 50 X1 plus 40 X2 plus 45 X3. All right. And then we have our constraints. So you subject to or whatever, just constraints. And there's a few things. There's that old chocolate shortage, right? They only have 120 pounds of chocolate. And two of the things require chocolate. Fudge requires 20 pounds. Creams uses 25 pounds. The pralines don't use any chocolate because they're like candied nuts, I think. So anyway, 20x1, right? I don't want to write it there. Let me write it down here. 20x1 plus 25x2, 25 pounds of chocolate for a batch of creams. It has to be less than or equal to 120. So they can use less than that, but they can't use more than that. All right. Then you have two other constraints. You have machine hours, 42, and you have 56 work hours for the people. And so you got to look. The cooking and processing, that is talking about the machine hours. So that's going to be 120 minutes for fudge. That's 2 hours because we were doing hours, right? So 2x1 plus 150 for chocolate cream. So that's 2.5 or 5 halves. X2. And then finally 200 for pralines. So that's 3 1/3 or 10/3, I'm going to say. And that's X3. And that is for the, what was that again? The machine hours. That's got to be less than or equal to 42. And, this was a little unclear. It just says for fudge. It doesn't say for a batch of fudge, but I think it does mean for a 100-pound batch. So I think we're good there. We can actually multiply this to get rid of the fraction. And I mentioned this in class, or at least one of the classes. You can multiply by 6. However, I think you want to put in the slack variable first. So like, plus S2. And when you multiply by 6, that S2 should really get multiplied by 6 also, because that way the slack variable is like the number of hours that are not used on the machines instead of like the number of 6-hour periods. You don't want to like get into that. So if you're going to multiply by something, it's better to have the slack variable in there first before you do it. All right. Same idea then on the packaging times, right? And this is minutes per 1 pound box. This is like really annoying, right? So 1 minute for a 1 pound box, but we need to multiply by 100 because it's a 100 pound batch. And then you need to convert to hours. So it's 1, 2, and 3 respectively for fudge, creams, and pralines. So 100 minutes for a 100 pound batch of fudge. That is 1 2/3 hours. So that's like 5/3 x1. 2 times 100 is 200. That's going to be 3 1/3. That's like 10/3, right? Hours for x2. And then for 3, it's going to be 15/3 or 5 for x3. And that has to be less than or equal to 56, the number of like work hours available. And again, if we're going to multiply by 3 to get rid of the fraction here, first you want to add S3 in here, plus S3. And then I think that was it, though. I think we just have the 3 constraints with the 3, the 3 slack variables then, right? Like S1 will be in that first one. So I think we're good. I'm going to go ahead and just kind of shrink this up a little bit. Guess I'll erase those lines while I'm at it, just to make some room for my, what do you call it? The matrix, the simplex tableau, right? Fancy name. All right. So let's set up at least that initial simplex tableau, and then maybe we'll go to a fresh screen. So constraints, the first constraint is this one, 20, 25, 0, and then 3 slack variables, 1, 0, 0 for the 3 slack variables, and then 0 for z, and then finally 120. Okay, the next one, I am going to multiply this one by 6 to get rid of these fractions. So if we multiply by 6, we're going to have 12. And then it's going to be 15 for x2, right? And then it's going to be 20 for x3, because when you multiply by 6, the 6 and the 3 reduce, multiply the 10 by 2. Same idea with the 5 halves. And then 0, and again, I was saying you want to add the S2 in first, so it gets multiplied by 6. It's going to be a 6 there, and then 0 here, 0 for z, and then also that 42 gets multiplied by 6. So it's 240 plus 12, 252. Okay. And then we're going to go ahead and do the last one there, the last constraint, and then the objective function at the bottom. I'm going to multiply this one by 3, so I'm going to have 5, 10, and 15, 0, 0, and then 3, because the slack variable S3 gets multiplied by 3 as well. 0, and then 150 plus 18, 168 when you multiply 56 by 3. And then finally, that last one, the last row is going to be from the objective function. So we're going to have negative 50 for x1, negative 40 for x2, negative 45 for x3, because again, you're bringing those over to the z side of the equation. 0 for the 3 slack variables, 1 for z, and then finally 0 over here. So it's a little different than some of the other ones where we've always had this like identity matrix kind of in the midst there, since we multiplied a couple of our rows by a common denominator, right? But I think we're good. I think this is our initial simplex tableau, looking good. And now we're ready to start the pivoting process. So let's do it. Most negative indicator, negative 50. Divide over here, 120 divided by 20 is 6. 252 divided by 12. 12 times 2 is 24, so times 20 is 240. So it's not this one, right? Because it's definitely more than 6. 168 divided by 5. 160 divided by 5 is like, it's more than 6, right? 5 times 6 is 30. So it's not this one either. So it's going to be this one is my point. So I'm going to go ahead and set up down here. And for the first row operation, we're pivoting about that 20. I'm just going to leave it, right? Row 1, leave it alone. Row 2, I want to get rid of the 12 there. It's a little tricky. We can go to 60, right? We can do like 3 row 1 and 5 row 2. And I can already tell if I do like 5 row 2, that's a lot more than 3 row 1. So I'm going to do 5 row 2 minus 3 row 1. In that last column, right? I want to keep that positive. So I'm going to do 5 row 2 minus 3 row 1. Okay. And then we're going to do 4 row 3 minus row 1. 4 row 3 minus row 1. And finally, 5 row 1 plus 2 row 4. 5 row 1 plus 2 row 4. And let's do it. We get row 1 as is, 20, 25, 0, 1, 0, 0, 0, 120. 5 row 1 minus 3 row 2 is going to give us the 0 we want there. 75 minus 45 is 30. Oh, whoops, I'm sorry, that's not right. 5 row 2 minus 3 row 1. 5 row 2, that's 75 minus 75 is 0. Duh, that's what we wanted was the, well, no, we just happened to get a 0 there too. Okay, 75, 5 row 2, minus 3 row, yeah, that's right. 75 minus 75, 0, sorry. 5 row 2, that's 100 minus 0 is 100. 0 minus 3, what was that? 30 minus 0, 0 minus 0, 0 minus 0, and then 5 times 252 is like 2520 over 2, should be 1250, 1260. Minus, what is that? 3 times 120, so minus 360 is going to be 900. Unless I made a mistake there. All right, 4 row 3 minus row 1, that should give us a 0 there. And then we have 40 minus 25 is 15. We have 60 minus 0. We have 0 minus 1, negative 1. 0 minus 0. 12 minus 0. 0 minus 0. And then 4 times 168, I should be using a calculator here. That's going to be what, 640 plus 32, I think 672, minus 120 for row 1, which should be 552, unless I'm mistaken there. And then the last row, 5 row, what is that, 5 row 1, because that's my pivot, plus 2 row 4. Yeah, that gives me the 0 here that we wanted. We're going to get 125 plus negative 80. So that's going to be a negative 45. I'm sorry, positive 45. Positive 45, 125 minus 80. And then we've got 2 row 4. It's going to be a negative 90 here. So there is another pivot, right? Because we do have a negative indicator there. And then we have 5, 0, 0, and 2. And then finally, 5 times 120 is 600, and then plus 0, so 600. Okay, we will pivot again. We're going to use the negative 90 column, and 900 divided by 100, that's 9. 552 divided by 6. 6 times 9 is 54, so 540, which is less. So like the 900 divided by 1 is going to be less, just a little bit. So we're pivoting here, and so let me set that up. So we're going to leave row 2 alone, but for row 1, row 1's already got the 0 there, so that's nice. Row 2 stays. For row 3, we have to get the 0 there, so we're going to do 300, right? We're going to do 5 row 3 and 3 row 2. So 3 row 2 is like 2,700. 5 row 3 is going to be 2,500 plus 250. Already I'm more than 2,700. So I'm definitely going to do, plus 2 times 5 is 10, right? So it's going to be that minus the 2,700. So I want to do row 3 minus row 2 here. So I'm going to do 5 row 3 minus 3 row 2. Okay, and then finally, we're going to have 9 and 10, right? This and this. This one's annoying. So we're going to do 9 row 2 plus 10 row 4. 9 row 2 plus 10 row 4. And hopefully this will be the final pivot. I don't have time to do, I don't even know if I have time to do this one with this video. So I'll just really quickly, you know what, I'm going to do the last row and leave the rest to you and see if we're done pivoting just for fun. So I have row 2 and row 4. So that first column is going to be 0. I have 10 row 4, so that's 450. I have, this should be the 0, right? No, that's like negative 900 and positive 900. I have negative 27 plus 50 should be 23. So far, so good. I have 270 here, 9 times 30. I have a 0 here, and I have a 20 here. So this is the last pivot here. And then I have 8,100 plus 6,000 is 14,100. So I do believe that that 14,100 should be our, this should give us our Z max. 20Z equals 14,100, which should give us 705, I think. Z equals 705. Should be our Z max. It's going to happen when X2 and S1 and S2 are all 0. And then if we finish the other row operations, we'll be able to plug into those in order to find the optimal values for the other variables. All right, that's it.